In this video, we're going to break down the difference between atomic mass, atomic weight, and mass number. These terms are often used interchangeably, which can make things confusing. But by the end of this video, you'll clearly understand what each one means and when to use them. Before we define each term, let's review some basic information to help you prepare for what's to come. First, when looking at the periodic table, you can find a lot of useful information. Let's take carbon, for example. Carbon has an atomic number of 6. This tells you that every carbon atom has 6 protons. But carbon atoms can have different numbers of neutrons, and atoms of the same element with different numbers of neutrons are called isotopes. When you look at the periodic table, you will see a number under each element, like carbon, which has a value of 12.011. Sometimes this number is called the atomic mass, sometimes the atomic weight, and sometimes used as the mass number to determine the number of neutrons an atom has. So how do we actually tell the difference between these terms? Let's break them down one by one. Let's start with the mass number. The mass number is the total number of protons and neutrons in a single atom. So the formula is mass number equals protons plus neutrons. For example, let's look at carbon. A carbon atom has 6 protons. If it also has 6 neutrons, then mass number equals 6 plus 6 equals 12. So this atom is called carbon-12. The mass number is always a whole number because you're just counting particles, no decimals. However, if you're ever asked to find the number of neutrons an atom has without the mass number given, you can look at the periodic table to help you. For example, with carbon, you can use the 12.01 number to estimate the mass number by rounding it to the nearest whole number. 12.01 rounds to 12. So we use 12 as the mass number. Now that we have the mass number, we can find the number of neutrons. Remember, mass number equals protons plus neutrons. Carbon has 6 protons, so mass number 12 minus 6 protons equals 6 neutrons. Next, the atomic mass is the mass of a single atom, measured in atomic mass units, or AMU. To understand this, let's continue to use carbon as an example. If we take one specific carbon atom, like carbon-12, it has 6 protons and 6 neutrons. Remember, each proton and neutron has a mass of 1 atomic mass unit, so 6 protons equals 6 AMU, and 6 neutrons equals 6 AMU. Therefore, the total mass is 6 plus 6 equals 12. So the atomic mass of that carbon atom is 12 atomic mass units. Now, the atomic weight is the average atomic mass for an element. That means the atomic weight is the weighted average of all naturally occurring isotopes of an element. Remember from our last video, isotopes are atoms of the same element that have different numbers of neutrons. That means instead of looking at just one atom, we're looking at all the different versions of that element and averaging them based on how common they are. Let's go back to carbon. Carbon exists mostly as carbon-12, but a small amount exists as carbon-13 and an even smaller amount as carbon-14. When you average those together based on their natural abundance, you get atomic weight of carbon approximately 12.011. To recap, here's a breakdown of each. Mass number equals protons plus neutrons in one atom, whole number. Atomic mass equals mass of a single atom, very close to the mass number. Atomic weight equals average mass of all isotopes, usually a decimal, and the number found on the periodic table. You can see why many teachers and books use these terms interchangeably, just based on the carbon example we've been using. Carbon has a mass number of 12, an atomic mass of 12, and an atomic weight of approximately 12.011. While they are often similar, now you can also see how they differ. Here's one more concept if you're interested in how isotopes are used in real life, specifically in PET scans. A PET scan, which stands for positron emission tomography, is a medical imaging technique used by doctors to see how tissues and organs inside the body are functioning. It's often used to detect things like cancer, study brain activity, or check how organs are working. To do this, doctors use radioactive isotopes. Radioactive isotopes are unstable atoms that release energy, radiation, when they decay or change form. The half-life of an isotope is the time it takes for half of a sample of radioactive atoms to decay. For example, carbon-11 is a radioactive isotope of carbon. It has 6 protons and 5 neutrons, giving it a mass number of 11. Carbon-11 has a very short half-life of about 20 minutes. Half-life is basically a measure of how stable or unstable an isotope is. A short time is very unstable, so it is quickly changing to become more stable. That means after 20 minutes, half of the carbon-11 atoms in a sample will have decayed. After another 20 minutes, half of what's left will decay again, and so on. Because of this short half-life, carbon-11 is useful in PET scans. In this process, carbon-11 can be attached to molecules that the body naturally uses, like glucose. When this is injected into the body, active areas, like the brain or rapidly growing cells, will take in more of the molecule. As carbon-11 decays, it turns into a different element called boron-11 and releases a small particle called a positron, which is what PET scanners are able to detect. This allows doctors to create detailed images of what's happening inside the body. And because it decays so quickly, it doesn't stay in the body for very long. I hope this helps you have a better understanding of isotopes, as well as understand the difference between atomic mass, atomic weight, and mass number. If I missed anything or you have any questions, leave them in the comments below and I'll try my best to get back to you. Thanks for watching.